So we've got a problem here that we're asking for the empirical formula and the molecular formula, and we've been given the molecular weight, which allows us to get the molecular or true formula of the compound. We've got the percentages here, that'll give us the empirical formula. So we're starting out with the percentages, and what we're going to assume is we have 100 grams of compound, which means that each of these percentages, 38.6% carbon means 38.6 grams of carbon, 90.76% hydrogen means 9.76 grams of hydrogen, 51.56 grams of percent of oxygen means 51.5 grams, 56 grams of oxygen. So we'll start out with the carbon and we'll try and figure out the number of moles. So it'll be 38.6 grams of C. Grams of C on the bottom, moles of C on top. 1 mole, 12.01 grams. And we've got 3.21 moles of C. Next one, we've got hydrogen. That's our 9.76 grams of hydrogen. Grams of hydrogen, moles of hydrogen on top. 1 mole of hydrogen, 1.01 grams of hydrogen. And 9.69 moles of hydrogen. Alright, next one, we've got 51.56 grams of oxygen. Grams of oxygen on the bottom, moles of oxygen on top. 1 mole, 16.00 grams. And that's going to be 3.22 moles of O. So next what we'll do is we'll take each of these and divide through by the smallest one, which is the C. So we'll do 3.21 moles divided by 3.21 moles. And that equals 1, and that's for the C. Now we'll do the hydrogen, so that's going to be 9.69 divided by 9.69 moles divided by 3.21 moles. And that's going to be 3.01, which we may as well say is just 3. That's for the hydrogens. And the next one is the oxygen. That's 3.22 moles divided by 3.21 moles. And that's going to be 1.00, which will also be 1 as well. So that's for the oxygen. So you can see that the empirical formula here is going to be, now for C is to H is to oxygen. We've got 1 is to 3 is to 1, so it's going to be C, H, 3, O. The next thing we need to do is to figure out the true formula for the compound, so I'll get rid of all this. And the way we'll handle this now is that we will figure out the weight of the empirical formula, which is going to be 12 plus 16 is 28 plus 3 is 31. So the mass of CH3O is 31 grams per mole. And what we're going to try and do is figure out how many empirical formula units we can actually fit into 372 grams per mole. So what we do is we take the 372 grams per mole, which is the molecular weight of the compound, divide it by the weight of the empirical formula, and that's going to come out to be 12. So that tells us we can fit 12 of these units into 372 grams per mole. So the next thing we do is we take the empirical formula, we take it and multiply it by 12, and that will give us our final equation, which is C12, H36, O12. And that will be the true formula.